Good day class. Sa karon mag-discuss ta sa usa sa mga lessons for the last module, ang module 4. So ang first niya nga lesson is all about waves. So mo niya to na nga i-discuss karon. So ang wave ato una ang nomenclature sa wave. So we have a wave at the center. So ang wave, well, ang model niya or ang iyahang manifestation is of course kay ba naman ta waves kay mara siya curve nga nag-rise up, ang rise na pod and then may down, up, down. So kung ato siya i-visualize mo ni ang forma sa wave. So we have this rising and falling nga curve, manay ang pattern, and then ang wave pod of course na siya mga parts. Ang highest peak or ang highest point sa wave man siya gitawag nga kanang crest, and then ang lowest point mao pa gitawag nato nga trough. Okay, so kung inyo ma-notice atong wave, actually narin siya pattern nga gi balik-balik ra. So the same kanang principle, sa kanang kuan kaning nga linya nga ako i-drawing. So let's say if we have this type of kanang pattern nga ni ana siya, then may ana na pod ni ana. So as you notice kani siya nga curve hing repeat ni siya by this pattern kani ag circumference. So iya pattern is by U shape. So that pattern repeats until kung asa siya mo end. So the same thing with our wave, nagarepeat na iya pattern. As you notice, kung ato i-trace kung unsa iya pattern diri, so it start from this point, then goes downward. So it has a value downward and then goes upward, and then balik siya sa iya original. And then the same thing, mo go na pud siya downward, mo go upward, balik sa original. So as you notice, this is the pattern of our wave, and we have this length, okay, and this length is known as lambda. So lambda stands for the wavelength of our wave. So wavelength. Okay, wavelength. And then since we have wavelength, we also need to know kung unsa kapaspason ang occurrence ato ang kanang wavelength. And since ang wave kay ni travel man siya, so this is in motion, wave is in transit. So transit meaning nag-move siya. So at it travels, of course, naa siya'y velocity. So naay velocity ang atong wave. And ang iyang velocity, ang velocity sa wave can be quantified by using this formula, that is velocity is equals to the distance, which is wavelength, all over time. But since the inverse of time is frequency, so that's why we have F times lambda. So ang pasabot sa frequency class is kanang unsa ka kadali mo repeat ang pattern kani atong wave pattern. So kung ato na siya i-visualize ato frequency, suppose we have this manifestation of our wave. So if our wave mutaas, mubos, mutaas, mubos, mutaas, mubos, mutaas, mubos. So as you notice, mana ato our first wave. This is our first wave, and then the second wave is medyo kuan siya, dikit ang iyang wavelength, or mas mubo iya wavelength. So mubo iya wavelength. So if that is the case, the first wave, kay kaning first wave has a kanang kuan F here is kanang kuan lower. Nganong lower man ang iya frequency? Since taas ang ato ang wavelength. Okay? At I mean uh, ang pagbalik-balik sa ato ang pattern, di ba? Namatay pattern ana sa tong wave. So ang iyang pag-repeat siyang kaugalingon, medyo langay siya kay pataas naman, hintaas naman siya. Whereas diri sa number 2 ang iyang pattern, okay? Yung pattern dikit kayo. So meaning kadto siya mo cycle. First pattern, then second pattern na pod. Kato magud sila i-compare, mas dali ning wave number 2 mo balik sa iyang pattern. So that's why our frequency here is higher or greater. So this is the basic equation of our wave. Velocity is lambda over t, or frequency times lambda, wherein lambda is our wavelength. So since we're talking about wave, ato pod kuanon kung asa rin siya nagikan. What causes its propagation or its creation. So asa may nagikan natong wave. Actually, di ba, ang obviously nito makita ang wave kay kanang sa tubig. So kung atong kutawan ng tubig, mo-produce na siya og kuan na mga ripples. So na mga gagmay nga bawd-bawd. So naay disturbances nga nahitabo sa ato tubig, and that disturbances is what we known as the vibration. Okay, so vibration. So ang vibration di ay maunay hinungdan sa creation sa ato ang wave. So that causes the production of our wave. So mano siya, a vibration results to the creation of wave. Unya kanay platong vibration, this is associated with kaya itong vibration associated with force. Of course, let's say sa tubig, kung ato siya i-steer, so mo exert ta og force, and then ang force gi-transmit as a torque. Okay, ato man gi-steer. So na-exert ta og force ni ana para mo excite or para ma-disturb ang tubig sulod sa baso. So tungod di ana na-create ta og wave inside the glass. Mano siya, and not only water, even sa mga solid objects. So kato na pukpukon, kung natay pukpukon, we can also generate what is known as the sound wave. Bisag sa atmosphere, so kung mo storya ta, mo nang madungog sa uban, since ang kanang atong baba generate na siya sound due to the vibration inside sa kaning di sa to ang kanang kuan sa to ang kanang larynx o kanang sa pharynx. So mo generate na sila og sound waves niya, mo reach sa tag sa nato ka mga dunggan, mo na makabati ta sa tingog sa ubang tao. So man siya due to the vibration, mo nang na-create niya to ang wave. So ang wave class gi-divide ni siya into kanang kuan two major classifications. So we have, the first is natay gitawag nga mechanical waves. So natay gitawag diri nga mechanical waves. So from the word itself, mechanical waves, meaning kuan siya, naa siya external source para ma-create siya. Okay, from the word itself, mechanical, so there is motion and there is movement. So para ma-generate din ang wave, so na external source nga makapa nga makapa generate og mechanical waves. Then ay kaduha is man siya ang wave nga ni occur naturally. Iya tawag is the electromagnetic waves. Electromagnetic waves. Kani siya ato na siya makitaan sa mga mga radioactive nga mga materials, even sa ato ang universe na sila yung mga electromagnetic waves sa ato mga stars, sun, and other mga ato ang mga galaxy. So they are natural because we can see this in our surroundings, and they exist naturally since the beginning of the universe. So muna siya mechanical waves. Ang mechanical waves class, ang iyang visualization is kuan siya. Um, ang iyahang koan ay porma is nakaparallel siya sa direction kung asa siya padulong. Let's say this is the direction of our mechanical waves, so muna siya as represented by this black arrow. Now ang iyahang porma sa mechanical waves is nakaparallel iya movement. So let's say kani siya na ay portion nga dikit, then na ay portion nga nagkalagyo na pud ang waves, then midikit na pud siya, and then milayo na pud hantod pa daw nga direction. So as you notice, ang composition sa mechanical waves is nag-compose siya aning mga compressed nga parts. So gitawag na siya nga compression, meaning ang wave particles dira kay closer to each other, so mas lagi gidikit. After nila gidikit, of course mo sila mo bounce back, so mo nang palayo na pud sila, mo nang naatay region nga medyo lagyo ang mga wave particles sa ato mechanical wave, and we call this one as rare fraction. Okay, again, ang direction sa ato mechanical waves is parallel, or the orientation, the orientation of our mechanical waves is parallel to the direction of our mechanical wave. So nakaparallels ang iyahang orientation and comprise mostly of compression and rare fraction ng mga kanang sections. Now, sa electromagnetic waves, kani siya nag-comprise ni siya og duha ka mga components. Let's say if we're going to take this black arrow as the direction of our electromagnetic waves. Now, kani siya ni duha ka elements nga na-involved. The first one is the magnetic field, the electrical field. Of course, electromagnetic waves comprise of two, electric field and magnetic field. So, if we're going to consider this electric field, so a wavelength nga paubos nya musaka, paubos then musaka. So, mo na siya yung direction. Naka-perpendicular ang orientation sa atong electric field sa direction sa ato ang wave. Nakingana siya. And then, di ba sa ato discussion sa katong module 3, okay? Katong module 3 about magnetism. So, if we have an electric charge, of course, at the subatomic level, nagapossess po na sila og kanang kuan. Nagapossess na sila og electromagnetism. So, naka-generate ta diri og magnetic field, and the magnetic field is always perpendicular to our electric field. So, paing-ani siya. Instead nga pa up or down siya, ang iya direction is pa left, then mga na pud sa right, then left na pud, then right. So, as you notice, still the magnetic field is perpendicular paghihapon sa ato ang direction sa atong motion, and also to the electric field. So this is our magnetic field. And then this red one, katong yun ganiha, mo na siya to ang electric field. So again, these two elements, they are, their orientation is perpendicular to the direction. So, naka-perpendicular sila. Perpendicular. So, mara na ang diferensya sa mechanical waves and electromagnetic waves based on their appearance or ilang kanang visualization or manifestation. So, ang mechanical waves kay orientation sa mga elements kay parallel to the direction of the wave. And then for electromagnetic waves, composed of two elements, the magnetic field and electric field, in which they are kanang at right angle with each other, and then they are also perpendicular. They travel perpendicular to the direction of the wave. So, mana siya. And then, kani mechanical waves, di ba? Nag-travel ni siya. So in order for the kanang kwan class, in order for the mechanical wave to travel completely on a certain space, nag-need ni siya class, si mechanical, nag-need ni siya og matter. So needs matter, or this matter is considered as a medium. Needs matter as a medium to propagate. So unsa to yung mga three types of matter? We have solid, liquid, and gas. So if walay matter nga present, then mechanical wave does not occur. So unsa man nga mga cases atong vacuum. So ang perfect vacuum, walay solid, walay liquid, walay gas dira. So dili maka-travel dira ang mechanical waves. And I think na may idea kung unsay mga example sa mechanical waves nga dili mo travel sa vacuum. So mo na siya sa mechanical waves. However, sa atong electromagnetic waves, it does not need any matter. So no matter needed. But if na matter, okay ra gihapon. Kay both mo travel siya even if na ay matter or wala. So meaning kung dili siya na og matter as a medium to propagate, so maka-travel siya, so it can travel on a vacuum. Can travel on a vacuum. Of course, nga naman. So as what I have told you earlier, most objects or particles nga mo-possess siya og electromagnetic waves kay mga radioactive nga mga elements or compounds. So kanang mga atong kanang stars and sun, kana po ato sun sa outer space. So they are separated by an empty space or a vacuum. So wala may matter nag-exist beyond sa ato ang Earth's atmosphere. So nganong makareach gihapon ang init gikan sa sun due to this principle kanang electromagnetic waves. Maka-travel gihapon siya bisag walay matter. So mao nang makaabot gihapon ang init gikan sa sun nga bisag layo kaayo siya. Okay. So next is ato pod mechanical waves. Another characteristic is they travel. So they travel back and forth. They travel back and forth. So meaning mo bounce sila, mo bounce. Mura ba ni siya mo labay kag bula sa bungbong mabalik sa imuha. So mao po ni if a mechanical waves kay makasugat kay siya mga obstruction, okay? So mo bounce siya na ay reflection nga mahitabo. Whereas sa electromagnetic waves, since they are kanang composed of electric and magnetic fields, so mukaan sila, they will penetrate. Okay, they will penetrate the material. So I think ano may idea ni ini. So mo penetrate siya, but not all types of electromagnetic waves nga mo penetrate. Na uban nga medyo low na ya energy, so mo bounce na lang. But sa katong mga electromagnetic waves nga mga deadly kaayo, like ang ilang frequency kay taas, shorter ilang wavelength, mo to sila yung mga highly penetrated nga mga highly penetrative nga mga waves, electromagnetic waves. So kaya to sila. So ato enumerate pod unya ang mga example niini. Okay, so if this is the case nga ang mechanical waves day kay mo bounce, ang electromagnetic waves kay mo penetrate, so naatay another term nga mo represent aning duha. So we can also call this one as, for mechanical waves, pwede natin siya matawag as longitudinal waves. And then kaning electromagnetic gitawag po ni siya og transverse wave. Okay. Nganong longitudinal pod? So, from the word itself, longitudinal meaning along. Along siya sa direction. Sa to ang kanang wave. So, meaning parallel. So, mo na atong first definition ganiha parallel because, of course, ang longitudinal nag-indicate siya nga kanang parallel ang orientation sa ato ang mechanical, sa ato ang element sa ato mechanical waves. So, mo na mechanical waves can also be a longitudinal waves. Pero, di lang siya ingon nga puro lang longitudinal waves and mechanical waves because there are some mechanical waves nga either longitudinal or transverse. Transverse din eh. Dili transverse, transverse. Transverse ni. Transverse. Okay. So again, longitudinal, parallel. And then ang ato ang transverse wave kay perpendicular na siya. Perpendicular. Okay, so unsa may example sa ato ang mga mechanical waves, specifically longitudinal waves. So ang good example niini is ang ato ang example ang ato ang sound. Of course, di ba ang sound kay mo bounce back man nya na nag-comprise na siya og compression and refraction. So nganong longitudinal siya kay parallel man ang element sa sound sa iya direction and then mo balik po di ang sound. So kung once maka-reach ni obstruction mo balik siya mao nang natay gitawag nga echo. So mo echo ato ang sound bubalik sa ato mo nang makadungog punta sa atong gistorya while ago. So nga na. And then ang best nga example sa transverse wave are mga electromagnetic radiation. So we have electromagnetic radiation or mga electromagnetic particles. So kani siya ato ni ma-visualize ning mga electromagnetic radiation by the electromagnetic spectrum. So di ba namatay electromagnetic spectrum. So let's say ato i-drawing ang spectrum. So it starts from the shortest wavelength but higher frequency. And then hantod nga may gamay siya hantod nga taas na kaayo ato ang wavelength. So here ang pinakagamay og wavelength and then taas yung frequency is tawag niya kay mga gamma rays. Mano siya pinaka highly kanang penetrative. So gamma. Next sa gamma is natay X-ray. So kuyaw gihapon siya, that's why sa kung magpakuanta tag X-ray kausa sa ka tuig as much as possible kay kuyaw man i-expose ni sa radiation kay highly penetrative kay ni siya. Next is we also have ultraviolet. So next on the line is UV, ultraviolet. Then next is kaning siya nga part right here mo ni ang makita sa to ang mata. This is the visible light. Okay. So too much exposure pod niini maka-harm pod sa ato ang mata. Of course kay there still electromagnetic radiation. Then next after sa visible light di na pud ta kakita ani. So we need to have a special device para makita ni sila. So maning infrared nga mga rays. And then next is microwave. So mo ni ato ang gigamit pag init sa ato ang microwave na oven. And then lastly is mo na ito gigamit sa telecommunication. So radio waves. Mo na sila ang pinaka longest wavelength and kanang longest wavelength and shortest longest wavelength og kanang smallest frequency. Okay, again from left to right kung ato ta sa palefta highly penetrative kani siya kay si gamma gamay siya wavelength dako siya frequency. Nya nga ato ra makit-an sa ato ang mata is kaning visible light. Mo nang dita kita ng mga X-ray ug UV. So kanira nga portion na dra makita nato ang mga basic colors: red, blue, yellow, white, then katong black man ang dark. So mao ni siya. And then ato ni sila tagsa-tagsaon. So again, unsa hinungdan, what causes wave? So ang wave nagikan na siya sa disturbances, and we term that one as vibration. So naatay di gi-exert nga either force or any mechanical means para ma-create, maka-vibrate ta sa kabutang. So nay ma-produce nga wave. Then basic parts sa wave, we have crest, the maximum point, then we have trough, the lowest point, then ang wave kay kanang ang iyahang visualization is kana siya nana siya pattern nga repeats at infinity. So balik-balik ra yung pattern, and for a single pattern ang length sa usa ka single nga pattern kay gitawag na siya lambda o gidenote na as lambda, known as the wavelength. And the basic equation for wave is by using the velocity principle, distance over time, wherein ang distance ato kay wavelength, then divide by the time. So, kaning time mo siya ang period kung kanang unsa kadali ma-repeat niya ning ato ang pattern, more ma-travel niya ang wavelength. Or this inverse time nga expression, we can also denote that one as frequency, meaning unsa ka paspason kay ang frequency, this is cycle per second. Okay, ang usa ka cycle sa ato ang wave is mo na siya yung equivalent sa ma-complete niya ang usa ka pattern. Okay, or one pattern per second. So gidenote na siya as f. So again, kung magkataas ang wavelength, okay, magkataas ng wavelength, magagamay atong frequency. Kung magagamay atong wavelength, magkataas ato ang frequency. Okay, so next is ang two major classifications sa wave. We have mechanical waves, mo na siya ang mga waves nga ma-produce due to external vibrations such as the sound. So maka-produce lag sound tungod sa kanang working principle nato sa tong kaning sa tong liog kaning sa larynx and sa pharynx. So na-drive marag drum nga mo-vibrate. So mara siya kanang tissue mo-vibrate na siya, so maka-produce ta og kanang disturbances sa surrounding air. So mao makabati ang uban tungod kay mo-vibrate ang air particles. So meaning natay medium, kay ang mechanical waves needs matter as a medium to propagate. So mao nang makadungog ang uban kay mo reach man na sa ilang mga dalunggan. Then kani po mechanical waves mo bounce ni siya. So unlike electromagnetic, ang electromagnetic kay very deadly and kanang danger kani siya kay mo penetrate ni siya sa material. And then it comprises of two elements, electric field and magnetic field, which travels perpendicular to the direction of the wave. So other term for mechanical waves is longitudinal waves. Then for electromagnetic, transverse. So manis lang mga example. Good example for mechanical waves is sound. Good example for transverse wave for electromagnetic is the electromagnetic radiation. Starts from the gamma, highly penetrative, until the radio waves, less penetrative. Manigamit sa ato ang communication. And if you want to know kung unsa nga klase sa wave, that is both transverse and longitudinal. So natay gitawag nga seismic waves. Okay, seismic waves. And I think familiar na mo ani, mo na siya ang waves nga nagagikan sa earthquake. Okay, due to the vibration inside the earth's the earth's lithosphere, so nag-shake. So natay gitawag nga kanang natay primary waves. So nagikan na siya sa epicenter, and then may travel siya sa earth's crust, then towards the earth's surface. So kanang earth's kanang surface wave nga nana sa atong ma-felt, mana siya gitawag nga Rayleigh nga waves, still part of the seismic waves. Again, kaning seismic waves duha ni siya can either be longitudinal and transverse. Okay, so by having this nomenclature sa atong waves ato tagsa-tagsaon, meaning we're going to quantify each of them starting by the vibration. Okay, unsa man ato i-measure kung how much vibration ang ma-produce sa ato ang sa ato ang kanang sa ato ang butang. Okay, so let's start quantifying the source of wave kani vibration, and we're going to tackle again since na-tackle man na to nga kani siya nga class kani siya nga topic kaning SMH. This is a simple harmonic motion. So ang simple harmonic motion, again just a review, this is a periodic vibrating motion. So periodic vibrating motion, so meaning paulit-ulit din na siya fashion nga gi-follow or na siya pattern nga gi-follow, and then na siya restoring force, so has restorative force in order to keep its motion periodic. So mo siya balik-balik, mo up down up down up down para ma-maintain niya ang iyahang harmonic nga motion. Okay, sa simple harmonic motion natay mga kanang key terms nga ato ang pangitaon. So we have here key terms or mga parameters nga present niya. The first one is the frequency. Okay, ang frequency again mo siya ang cycles per second or per unit time, meaning unsa ka paspason niya ma-repeat ang iya na generate nga pattern, kay naka periodic pattern ni siya. So kung mas paspas, mas kuan ni siya, mas mubo ra ang iyang pag-complete sa usa ka pattern. Then next is we have amplitude. Since magkuan kami siya, mo goes up, mo goes down, so na siya crest and trough nga ma-generate. So ato i-quantify kung unsa katas aning mga crest. So mara siya, this one quantifies the magnitude of our crest and the trough. Quantifies the magnitude of the crest or the trough. Okay, mo na siya ikaduha amplitude. Ikatulo is natay gitawag nga period, meaning mo ni siya ang time nga ma-complete niya ang usa ka cycle. So time to complete one cycle. So kung inyo na kit-an class, kung inyo na observe, ang period is just the inverse of the frequency. Frequency. So mara siya. Then nasa may mga example sa ato ang mga simple harmonic motion. So natay duha, we have two basic examples. So tay butang two basic example aning simple harmonic motion. So two basic examples of simple harmonic motion, SHM day dili SMH, SHM. So una kay mutakol ta sa an object suspended by a spring. So nagbitay ni ang object niya, naka-attach siya sa spring. Ikaduha is a simple pendulum. A simple pendulum. Okay, mo na siya ato ang i-quantify kung pilay frequency sa usa ka object nga suspended by a spring, pila po diya period, and then also for a simple pendulum ato i-quantify iyang frequency and kana iyang period. So here, since nagdeal man putag vibration, actually naay duha ka mga two major types of vibration. But una is gitawag na siya og free vibration. Ma-manifest na itong free vibration if let's say na ay usa ka setup sa basic SHM. Let's say an object suspended by a spring. So when we say free vibration, if nalantay initial nga disturbances or initial nga disturbance, let's say atong gipull ang kanang object, so what happens is magsige siya og kanang vibrate. So mag-go upward siya, mag-go downward due to the spring. So kana siya, it will keep on going unless kung naay air. So in a perfect vacuum, walay air resistance, so mag-continue gina siya. So ang iyahang wave nga ma-generate kay harmonic. So mana siya ang free vibration. However, ang force vibration ay ikaduha is mo na gitawag nga force vibration. Meaning sa force vibration is nag-apply kag constant force sa usa ka object or sa usa ka setup para mo-continue siya og vibrate. Mag-continue siya og karang follow sa kaning gitawag nga periodic motion. So naa kay external source ani. So ato butang need constant external force or anything or any. Tapos here for free vibration only needs initial force or initial disturbances. So mara siya kung i-remove na to nga force, so mo continue na siya. Whereas si force vibration din siya mo continue kung hawaon ning ato ang external force. If na mag-apply tag constant external force throughout its motion, so mag-continue siya vibrate. Kung ato siya tangon, na mo ka man point nga mohunong gid siya. Okay? So man siya ang ato ang mga definitions and principles nga magamit nato pag analyze of simple harmonic nga motion. So focus ta aning duha kaning mga basic examples sa ato ang simple harmonic motion. Kaniya ato ang an object suspended by a spring, then a simple pendulum. Okay, so start ta sa ato ang kanang an object suspended by a spring. So tibutang object suspended by a spring. Assuming this is a free vibration, meaning ka osarata bibira sa ato ang spring, then ato siya gibiyaan nga mo oscillate siya. Okay, na oscillation nga mahitabo. So here, let's say we have a wall, and then sa wall na si spring, then nadra ato ang object. Let's say man siya iyang imaginary nga equilibrium position. Okay, so let's say we have here our F initial, meaning our initial external force ang gi-apply. So what happens here in the second figure is makuha na ni siya mainat. So mainat siya, mga to siya sa lowest point. So this is the trough side or the trough nga kan mo na siya ang location sa trough, meaning may ubos siya tungod kay himbirata. So naman ta diri if initial, of course this one is already removed. Now since as what I have told you for simple harmonic, naman siya gitawag nga restorative force, meaning naay force nga mo pabalik niya sa iyang equilibrium position, because this is its equilibrium position. So this is EP, equilibrium position. So natay restorative force. So kani siya restorative. Kaya ito i-erase kaya marag di na maklaro. We have here RF. Muna siya ang restorative force. So assuming mo na ito ang equilibrium position. So lampas na siya. Tungkol kay gibira man siya initially. Next is mga ito na po siya sa babaw. It reaches its highest point, and we call that one as the crest. Okay, kung ito siya i-convert into a wave. So kanina compress ang spring, then we go siya upward na siya di ang location, and then of course nanapod siya yung restorative force para mobalik siya sa iyahang equilibrium nga position. So nga siya class RF gihapon siya. So kanina siya this repeat itself. Now if walay air resistance, kaya of course kada travel pod ani ato ang kuan na maka-experience tag air resistance niini. So if walay air resistance, then we can guarantee nga mag-continue ni siya ag-oscillate. Now if we're going to trace ang position niini, so starting from here, the equilibrium position, so matulog ubos, then misaka na pod, then maubos. So therefore ni follow gid siya sa wave nga pattern ng ato ang spring, I mean atong object that has a mass and suspended by a spring. So in this setup class, of course, atong object, so our object has mass m, and of course since we're using spring, so ang spring na siya gitawag nga, kung nakahimdom mo, K. So K stands for the spring constant. Napagitawag nga stiffness of the spring, na iban gitawag nga force constant. So mana siya na atong spring gidenote as K, mara siya ang spring index or spring constant. So diri ato i-quantify itong duha ka parameters. Una is ang frequency, meaning kung sa kapaspason ning kani ang harmonic motion sa ato ang spring, object suspended in a spring. Okay? So kung mataas tag frequency nga mahimo diri, meaning grabe kani kapaspas mag-oscillate ang ato ang kanang object nga nakakabit sa spring. So let's start with let's start with the frequency. How are we going to solve for the frequency of a simple harmonic motion for spring given the parameters, that is the spring constant and the mass of the object? So by having this, or by a summation of forces, since this is in vertical motion, diba, we know that the accelerating force, that is FA, is just equal to the spring force. Okay, now if we're going to transpose the spring force on the left side, so may siyang FA minus FS is equals to 0. We all know that FA is just the mass multiplied by the acceleration of this force. So acceleration experienced by this restorative force. So ma-experience niya dira ay mo change na yung acceleration, bira na pud siya. So ma-increase na pud yung velocity sa pag-travel. So acceleration is the second derivative of our displacement. So I'll just label this one x double prime minus the force here is kx. So kx is equals to 0. Again, this is a differential equation. But since wala pa man mo subject niya na, then jump na lang ta kay di mo ganang gamit niya ni para ma-derive ang frequency. So here, ang frequency nato f from this one, f is just equal to the square root of k over m. So muna siya. Since namatay duha ka parameters ang mass object o ang k sa spring. That is not the k of the object. Ikaduha, we have the period. Okay. Ang period, simple that is the inverse of the frequency. And in terms of second man, so atang formula mahimong period that is t is equals to 2 pi over the frequency. That is equals to 2 pi square root of m over k. So mara siya ato atigamaan. Mara siya ato atigamaan class. So kani frequency, then this one is in period. So the units for frequency, actually kani siya naka-kuan pa ni siya diri naka region pa ni, region per second. Okay, so kung imo na change into cycle or into revolution, so convert na lang. That is one revolution is 2 pi region. Ang period diri automatic, ang kuan diri is in second by unit analysis. Okay, mo na siya ang object suspended on a spring. Ikaduha, para sa ato ang simple harmonic motion, is we have our simple pendulum. Okay, sa simple pendulum, natay object nga gi-suspend by a string. Okay, you have here an object with mass m and a string with a certain length. Okay, so kani ato ang simple pendulum, actually mo swivel ni back and forth. So either on the left, then right upward, left on the right. Now, ang iyang equilibrium position niini sa atong simple pendulum is nasa center. So dira. Kaya if di na siya maglihok kung na external source na gid, dira na siya mo suspend, mo hang na siya by itself. And of course, it would reach at the maximum point. So na diri mo reach na siya dira. Okay, na-assay daw ka maximum points. And now, since ang basic definition sa harmonic motion, simple harmonic, na siya restorative force. So asa man ang restorative force sa simple pendulum. So since nakasuspended siya, so this is influenced via gravity. So therefore, ang force nga ma-restore nila is equal to the gravitational force. And also here, also on the left side, so diri add mao po ni ang direction sa to ang gravitational force. So that's why magre-series siya paubos na pod, mo taas na pod. Taas, paubos. So yan na siya. Nantay daw ka parameters ni ini ang length sa ato ang wire nga gigamit ug ang mass sa ato ang object. So again, di gihapon ang pag-derive niya ni sa iyang mga kuan, sa iyang frequency and amplitude. So I mean frequency and kanang period. So here ato lang so directly ang lang relation. So for a simple pendulum, calculating for the frequency. So the frequency here is just f is equals to the square root of the gravity all over the length. Here frequency is in per second. So unit analysis. This is per second or this is in, let's say, cycle ba na siya, cycle per second, and we'll know that 1 cycle per second is equal to 1 hertz. Okay, 1 hertz na siya. Kung nagay makita nga hertz, pasabot frequency na siya. Kaduha, if the second one, t is equals to, we have here 2 pi over f. 2 pi over f, or that this is just the same as 2 pi square root of L over G. And the unit here is, ang unit diri is in seconds. So, that is for the frequency. And the period also. So, ato na ikuan ay kaduha. Kaduha, this is the period. Ato balikod, ato erase. This is the period. Okay, yun na sa class. Okay, sa ato apon ko ang class, kaning simple harmonic motion, since we're dealing with vibration class. Kanang ato po na siya ma-apply in real life. And then diri ato pod include diri sa atong simple harmonic motion na gitawag nga resonance frequency. So kaning mga frequency nga atong nakuha diri, kaning sa spring, gamit kani siya for any other object nga na sila'y kaning constant nga k, because k is not only for spring, because k generally term as the stiffness of a material. So ang spring, even our kanang mga steel rod na gina sila mga stiffness gapon represented by k. So if they have stiffness, and then if they have mass, of course, obviously na gina sila mass. So therefore na sila frequency. But that frequency, of course, we cannot feel that one. Let's say kung ato na siya i-excite ng mga kanang atong mga rods, steel rods, tingin na siya mo kan kay taas kay lahang gitawag nga natural frequency. So kanang natural frequency ato na siya i-discuss karon. So punta ta sa gitawag nga, importante ni siya nga kaning ikatulo, kaning gitawag nga resonance frequency. So the third one is the resonance frequency. So when we say resonance frequency, this is a condition. So condition is here wherein the external, okay, wherein the external frequency or the input frequency sa ato ang system matches the natural frequency of the system, is equals to the natural frequency of the system. Natural frequency of the system. Now we'll know that the general equation for frequency, or the general equation of our natural frequency, so ito siya i-abbreviate as Fn. This is our natural frequency. Muna siya ang inherent nga frequency sa ato ang material, is just equal to the square root, okay, the square root of k over m. So the units here is in radians per second pa na siya. So if you're going to convert that one into revolutions or cycle, again revolution is the same with cycle, because other unit for frequency is hertz, diba? So napod tayo hertz, Hz, hertz. Okay, mo na siya ang basic na formula sa ato ang natural frequency. However, for external frequency, that is Fe, external frequency, kana siya either given ni siya or dapat pa i-measure. Okay, so para mahitabo ning resonance nga condition, it should be that Fn is equals to Fe. That is the natural frequency of a material matches the external frequency. So how are we going to visualize this? Let's say na atay material. Okay, natay material nga kaning rod. Let's say this rod is fixed. Aning kanang kuan, ano siya nga structure, so fixed siya ani. So assuming we apply some vibrations sa atong system. So we apply vibration here. We have a source of vibration. Ato siguro na siyang giyug-uyog yun sa ba. So we have here an external force. An external force. So we have here an external frequency, Fe. So kanipod si kuan, nagina siya stiffness, that is K. And of course, it has mass. Ato ang rod. Now, with the external frequency class, ang mahitabo is vibrate na. So, pas-pas ang vibration na nato ang steel rod. So, more or less, mga na siya. Well, this is just kanang to visualize you. So, mag-excite siya. So, mura siya og misabay sa external frequency. Okay. External frequency na siya. So, Fe. Of course, class, kani siya with stiffness value and the mass na siya inherent nga frequency. Okay? So, if magmatch gina, if Fe is equal to Fc, therefore, kusog og tabyog. Kusog na kay nagtabyog ning ato ang material. Yung wala na gini, musabay na gini siya. Musabay na. So, if aya pasabay is greater na kayo, what happens is saman, say may tabo. That is Fe is equals to Fc. So, at resonance pa ni. At resonance na. At resonance. So, meaning sa second nga figure, ato na equal nga, this one is, the external force is less than pa siya. So, less than pa sa kanaang natural frequency. External frequency is less than sa natural frequency. So, this is not Fc. This is Fn. Na lipat og butang. This is natural frequency. Natural frequency. So, if less than pa, so, this one is good. Meaning, okay pa ni. Meaning, wala pa yung manifestation na ito nakita nga nagluhag-luhag na siya, kusog yung vibration, less pa, so okay pa. However, at resonance class, for immaterial this is fatal or delikado ni nga naman tungod kay kung match na gali ang atong external frequency sa natural frequency sa material, may tabo is mo fail. So, ma-damage ni siya. Mo fail ni siya. Meaning, mo-generate ang mga cracks kaya di na kaya itong gitabid-tabid may uyog na gid siya nga di na makaya siyang stiffness, so mo-fail siya. Again, mo na siya delikado sa sa material kung mo reach na siya in a condition nga mag-resonate na siya, meaning mo equal na yung natural frequency sa external frequency. Delikado na. However, napoy advantages ang ato ang resonance nga condition. So, tibutan diri advantages or advantage of our resonance frequency nga condition. So, asam rin magamit nga ato ni siya mapakinabangan. So, let's say naatay kuan diri di ba HP, so or the RMN, let's say RMN Cebu. So si RMN Cebu nag-broadcast siya, di ba? So nag-broadcast na siya na siya frequency, di ba? This is a radio wave, so na frequency Onya ay frequency, let's say 97.1. Say 97.1 kilohertz. Manay frequency sa yung radio wave. So now mo reach up na siya within the Visayas nga area. So let's say dool ka Cebu. So imong location na diri. So naa kay radio dira. Okay, you have this radio device. Now, kanang radio device mo pick up na og incoming nga mga radio waves nga signals. So dira yan ang ma-pick up. Now, ang kana siya, so kani siyang radio signal ha, sound na siya mo nang kung pagsulod na sa radyo ato na siyang mabatian. These are sound waves caused by the radio waves or radio waves. Well, radio waves pa rin siya. Radio waves pa rin siya because ang radio waves by the use of kanang mga electrical nga mga devices sulod sa radyo, maka-convert niya ang radio waves into electrical signal, and from electrical signal ma-convert siya into sound sa kanang sa atong ang speaker. Kaya ang speaker na siya magnets dira. So mag-vibrate na, mo-produce siya og sound. So again, nagikan ni siya sa radio waves. Ang transmission sa signal kay through radio waves. Okay, so ang kani ato ang radio device, of course na siya frequency po dara. Kay para ma-receive niya, okay, para ma-receive niya ang sa radio wave, dapat mo match iyang frequency. So na po na siya frequency nga i-emit. Let's say atong radio device na siya frequency pod na. Okay. Now dapat in order for the radio device nga mabasahin niya iyahang kani ang frequency nga gi-release sa taga RMN, so kailangan na naman ni FE. So we consider this one as FE, that is the external frequency gikan sa RMN, and ang radyo na siya iyahang kaugalingon natural frequency. Okay, take on dire natural frequency, we have here FN. Okay, so dapat para ato siya mabatian, of course ang principle sa mga frequencies nga atong dapat mabatian kay dapat equal. So meaning na siya sa resonance nga condition. So that is to hear, okay, to hear the signal of RMN, FE, that is the external frequency nga gikan sa RMN, should be equal to the frequency or the natural frequency of the radio. So mao nang mag-tune ta. Mao nang we have tuning. We have here tuning na principle. So kung mag-tune ta, hala ato ilisuon nga ang frequency na sa tong radyo kay mo match na aning 97.1 kilohertz. So na siya mga electric devices nga to or mga electronics nga mga devices sa sud sa radyo nga mo generate og frequency. Mao nang sa mga ultrasonic nga mga frequency di na natong batian tungod kay very kana siya very high. Okay, so di na nato siya di nato ang batian kay ang ato ang makaya sa ato ang kanang dunggan is around 20 to 2000 hertz. So more than 2000 hertz di na nato mabatian tungod kay maro na kaya kung maka-produce pa tong ear o kanang more than 20,000 hertz. So naip dako nga posibilidad nga ato na siya madunggan ng mga kanang ultrasound. Okay, so mana siya ang gamit sa resonance. So gamit na sa ato ang pag-receive sa radio waves gikan sa ato mga radio stations or even sa kanato sa TV station. So kailangan i-match ang ilang external frequency o ang natural frequency sa radyo. So mana siya, again, good siya for communication but bad for structural nga side. Tungod kay sa structural nga side, kailangan i-avoid na. So meaning make a better design siguro sa imong structure nga maka-resist siya og mga external frequencies. Sa mga external frequencies, maybe external load kung na kay bridge, external load nimo kanang mga sakyanan nimo agi o bisan og kanang mga during storm. Kung taas na imong bridge, so naay posibilidad nga mo sayo-sayo siya kung gusto kang hangin. So mo nay bantayan kay kanang wind, of course, that is another external source of vibration. Mga kailangan na imuhang likayan. Okay. So, nata din mga sample nga problem. So, the first problem is all about spring. So, let's say we have here when a 2.5 kilogram mass is suspended from a spring. So, we have here is a spring, then ay mass nga nakakabit. Mass here has a value of 2.5 kilogram suspended from a spring, so the spring stretches by 0.05 meters. So due to its weight, we stretch siya, meaning may kuan siya equilibrium condition tunta supposedly. Of course, may stretch ni because of the Earth's gravity. So stretch siya og 0.05 meters. Very small lang gid. Meters. Okay, A pangita required here. Required is the first one is we're going to solve the force constant. Again, unsa tay other term for force constant? This is just the same as the spring index. So that would be K. And then B is if the suspended mass is set into vibration, so mo vibrate na siya, what will be its frequency? So F. Okay, so the first question is stable ang system, meaning wala nag-vibrate. So ato pangitaon ang iya K because kung ato na siya makita ng K, we can use this in order to solve for the second requirement. So A, solving for the force constant or also known as the spring constant. So K. Now, by summation of forces na lang. Summation of forces along the vertical should be equal to 0. So that is the force due to the weight of this mass just matches the force that is being exerted by the spring. Now, we all know nga the formula for force due to weight is just the mass times the acceleration due to the gravity of the earth. Then the spring force is kx by Hooke's law. Hooke's law na siya. So therefore, solving for k, we have mass times gravity divided by the displacement of the spring. So since ni-deflect man siya 0.05, so that would be our x. So mass here is 2.5 kilogram times 9.81 meter per second squared divided by x here is 0.05 meters. So most probably the unit for force constant is Newton per meter. Okay, so the answer here, K is equals to, after solve, that is 2.5 times 9.81 divided by 0.05. So the answer is 490.5. So our force constant is 490.5 Newton per meter. That is the value of our K for our spring. Now, solving for B. Solving for B. So that is solving for the frequency. So as it vibrates, so kung vibrate ni siya, so mapuan na siya og simple harmonic motion. So SHM. Now, going back sa ato ang discuss kaganiha sa formula sa frequency for a simple harmonic motion for an object suspended by a spring. So that is just equal to F equal the square root of the spring stiffness or the force constant all over the mass. Now, substituting, we have 490.5. The Newton here is in kilogram meter. Then 9 meters abos over squared. Divided by mass is 2.5 kilogram. So here, cancellation of the units. Kilograms sa upper, makansya sa lower. Mass here, meter, makansya sa meter. So what's left is per second. That is radian per second. So therefore, the result here is in radians per second. So we have F is equals to, that is square root of 490.5 divided by 2.5. The answer here is almost 14. That is 14 radians per second. If we're going to convert this into cycle, that is, we all know nga si 2 pi radian is 1 cycle. So divide by 2 pi. The result is 2.23. So that is 2.23 hertz. Butang 2.23 hertz. So you can have either radians or hertz. So ano yung answer sa first, second is man siya. Okay, 2.23 hertz. Okay, so let's have second example. Bridge. So let's say one of the supports of a bridge weighs 1000 newtons. So let's say natay bridge. So natay bridge. Let's say usa sa mga support kani siya weighs 100 newtons. So yung weight is 1000 newtons. Next, suddenly ang wind rushes towards the bridge, strong enough to generate a vibrating pulse of 120 hertz. So kani siya na wind nga mikuan sa to bridge. So we have of course an external frequency of 120 hertz. Okay, to avoid the bridge from collapsing, what type of material should be used for the bridge support? So required is the type of the material. Type of material. So solution. So here, since nakita man ta nga na word nga to avoid the bridge from collapsing, so para di siya ma-destroy, gamit nito nato ato ang resonance frequency nga principle. So we all know that at resonance frequency, we have Fe is equals to the natural frequency of the support of the bridge. So nganong gamit ang resonance? Kay dira sa resonance, ato makitaan kung unsay stiffness sa atong bridge nga mo-break siya. So kung makaibaw ta nga mao na ang stiffness, so meaning ato siya patasan. So mo na ato ang paliton nga material para sa atong bridge para maka-sustain siya aning 120 Hz nga external frequency. So ato i-solve, given naman si Fe, so we have here 120 Hz is equal to the natural frequency here is square root of K over M. So M here, since ang given kay weight man, so ato yung square root of K all over weight divided by the acceleration due to gravity. Rearranging natay kg all over the weight. So here, since si Fe kay naka-hertz man, now we're going to convert this kay on the right side, the natural frequency is naka-radians. So what we need to do here is 120 hertz, that is 1 hertz, or 1 cycle is equal to 2 pi regions. Now after this, square both sides of the equation. So kung saan ay mahitabo sa left side, 120 times pi times 2, then answer squared. So dako kayo. So we have here 568489.212135 region per second is equal to kg all over weight. Now solving for k, we have here the left side multiplied by the w all over g. Again, the left side is mo na siya. Ako lang gidinoto nga na. Or is what? So we have here 568489.2135 multiplied by the weight. So the weight here is 1000 newtons divided by the gravity, that is 9.81. So ang K, or the stiffness of the object, should be answer times 1000 multiplied by G. So ang naalan diri is kano lang ni kano siya, second squared din siya, second squared ni. So nani siya per second squared. This is Newton second squared, so this is meter per second squared. So therefore makancel na ni ang second squared, mo nang Newton per meter na lang. So the answer here is dako kayo. So we have a stiffness value of kani siya 57949970.8. So that is K is equals to 57.95. This is kan siya kanang mega newton. So mega newton per meter. Dapat mo na ang stiffness sa support sa atong bridge para makasustain siya sa external frequency nga gikan sa wind nga equal to 120 Hz. So mo na siya class, mo na ang gamit gid especially sa pag-design og mga bridge or mga structures nga exposed sa environment. So kailangan nimo kuanon ang kanang frequency nga ma-generate sa ato ang hangin or unsa pa nga mga external nga mga vibrations nga present. Okay, so let's proceed to the next. Ato po i-quantify karon ang katong gitawag nga longitudinal wave. Okay, so kanang recall sa tong longitudinal wave. So mo na siya ang mga waves nga ang ilang mga elements kay kanang parallel to the direction of this wave. So mo na siya. And then example of longitudinal waves kay nga to ang sound. Okay, so again recall sa ato ang basic wave equation. So recall ta again ang saragali to, that is the velocity of the wave is equal to the product of the frequency of the wave times lambda, where lambda is the wavelength, di ba? This is wavelength, and of course this one is our frequency. And of course ay pod kalimti nga this one is also equal to, meaning the distance traveled or the total distance traveled by the wave from one point to the other, and also the time nga yang git-take dira. So still the same. Next is, since ang usa sa mga example sa longitudinal wave kay ang sound or napay uban, so we're going to quantify kung unsa kapaspason ning longitudinal waves mo travel at different mediums kay di ba ang longitudinal wave kay part of a mechanical wave wherein it needs matter, solid, liquid, gas para mo propagate ni iyang wave. So unlike electromagnetic nga mo travel gyapon siya in a vacuum, unlike mechanical, so advantage niya diri sa longitudinal kailangan sa ato ang calculations nag-require gid siya og katong tulo ka mga forms of matter: solid, liquid, and gas. So in that three types of matter ato i-quantify kung unsay speed ana niya. So we have here the speed of our longitudinal waves at different media. Okay, so again ang longitudinal waves can either be a sound wave or other types of this wave. So first is ang solid. So solid. Next is natay liquid. Then ikatulo is natay gas. Of course, ang speed sa wave kay ba naman ta mas paspas siya mo travel sa solid, then next is sa liquid, last ang gas because of their molecules. Kay si solid compact mas compact, so compact eh molecules, so therefore ang vibration kusog, whereas for liquid mas medyo kanang lagyo-lagyo iya mga molecules, so therefore it will take kanang extra time nga mo bump sila with each other or mag-collide sila so that na vibration nga mo occur. So it will take much longer time. And also for gas, mas samot, mas dako gid nga time since katag kaayo, lagyo jud kaayo ang mga molecules. So for solid, the velocity of our longitudinal wave v is equal to the square root of our Young's modulus y all over the density of the solid. And by unit analysis, Young's modulus is in Newton per meter squared. So if you are familiar with this, mura ni siya og unit sa pressure, that is force per square meter. Then sa ubos is density. So density is in kilogram per cubic meter. So ngano kaha nga nahimo ni siya og velocity? So ato bungkagon si Newton, may mo siyang kilogram meter per meter squared, then second squared, divide by kilogram per cubic meter. So here cancel ni si kilogram, ma-cancel ni si kilogram, cancel ni siya. Si mass diri ma-cancel ni siya, usan lang diri m, di ba? So that is pag-generate sa babaw by manipulation naatay meter squared per second squared. Since we take the square root based on the formula, so we have a final unit of meter per second, which is velocity. Again, for solid, that is the square root of the ratio of first one y, that is the Young's modulus. Actually, this is also the same as the E, or E, that is the modulus of elasticity. Katong sa ato ang topic sa stress and strain, modulus of elasticity. Again, the formula here is E is equals to Y is equals to the stress all over the strain E. So meaning, makuha day nato ang Young's modulus bisag wa ta nag-conduct og mga tensile test or compressive test. Kay pwede day kung naatay speed of sound ana nga material, so makuha din ta sa Young's modulus. So this is the other way of of getting the value of Young's modulus of a certain material without using the tensile test or compressive test. Ikaduha is for liquid. So for liquid, pagkuha sa velocity sa liquid is equal to, since ang liquid kay di siya pareha og condition sa solid, medyo lagi-lagi yung particle, so dili na Young's modulus diri kundi back modulus B over the density of the liquid. So again, same ra gihapon ang pag-unit analyze nini. Newton per meter squared gihapon ang back modulus. Density is still kilogram per cubic meter. So again, ato ikuan, that is our B here is the back modulus of the liquid, and rho, this is the density of the liquid kung asa mi pass through ang longitudinal wave. So mana siya. And finally, for gas. For gas, the velocity is just equal to the square root of the ratio of the product of the specific heat ratio, that is K, multiplied by the pressure of the gas divided by the density of the gas. Again, K here is unitless. So, tibutang K is the specific heat ratio. So, remember sa ato discussion sa module, kung siya, module 2, thermodynamics. So, K is equal to Cp over Cv. Mo siya, di ba? And for monoatomic nga mga elements or compounds, the value of K is approximately 1.4, like air. And for diatomic, baliktad ay for kani siya, for diatomic ni siya. So for diatomic, just like air, 1.46. So for diatomic, diamotic manoon. Take one. This is for diatomic air, 1.4. For monoatomic, ang iyang equivalent kay 1.667 approximately, just like the helium and hydrogen. So mana siya. Again, K is the specific heat ratio, so unitless ni siya. Putang nato unitless. Then ikaduha is the pressure, P. That is the, not air, that is the pressure of the medium, or pressure of the given gas. So pressure of the gas. Lastly is the density gihapon. Okay, density of the gas. Density of the gas. So muna siya class ang tigamaan to quantify the longitudinal waves. Again, nanginahanglan na siya og tulo ka mga media, solid, liquid, and gas. And for every media, na iyang kaugalingon nga formula for velocity. And of course, these three velocities still equal gyapon na siya kung i-by point and distance siya. Let's say, the total distance nga travel ana niya sa anang media o ang iyang time pod nga take dira. The same gyapon na siya because that is the very fundamental formula for velocity, that is the distance divided by time. So kani siya ako mag-ipang introduce niyo mga bago, that is the square root of Young's modulus other formula lang na niya, wherein what if given ang mga characteristics sa usa ka object, like for solids or liquids or gas. So yan na class, and yun na siya kalimti. So let's have some example. So we have here a radio signal problem. So in dire, on your radio, you have an AM and FM band. So when we say AM, that is amplitude modulation. FM means frequency modulation. So suppose a station broadcasts on two radio frequencies. So 630 kilohertz and 101.9 megahertz on your radio dial. So the speed of the radio wave in air is 3 times 10 to the power of 8 meter per second. Find the wavelength for each frequency. So the given here, so what given natay first frequency, that is idinotan to nga A, that is 630 kilohertz. Mana frequency F of A. The next F frequency ni B is equals to 101.9 megahertz. So mas paspas kini siya. And then naatay speed, that is the velocity of our radio wave. So since radio wave na siya, that is 3 times 10 to the power of 8 meter per second. So closely the same sa speed sa light, or the same good, 3 times 10 to the power of 8. Next is ang requirement. So required here is to find the wavelength. So wavelength for each frequency. So wavelength ni A, then wavelength ni B. So solution. Now start for wavelength ni A. So wavelength ni A, that is from the principal basic formula for wave. Velocity is equal to frequency times lambda, so that is for A. And since ang velocity for both frequencies the same naman kay they are using the same type of radio signal, that is radio wave. So therefore same na, that is 3 times 10 to the power of 8. So solving for lambda A is equals to the velocity A over the frequency. Again, don't forget to convert the frequency, that is ang frequency dara is cycle pa, so kailangan i-change pa into regions para makuha na to ang measurement sa lambda. So velocity here is 3 times 10 to the power of 8 meter per second. Frequency sa A kay 630 kilohertz. So kilohertz, para ma-convert into hertz, that would be 1 kilohertz, 1000 hertz, and then 1 hertz is 1 region per second. I mean 2 pi. 2 pi region per second. So simplifying, natay 3 times 10 to the power of 8 divided by 630 times 1000 times 2 pi. So the answer here is 75.79. So ang sukod siyang wavelength is 75.79. This one is in meters. Muna siya ang kang lambda A. So ato ang baksan, muna itong answer, first answer. Next is for lambda B. That is wavelength for the second nga radio frequency. So same na gihapon, we have VA, VB na, is equals to FB lambda B. So lambda B is equals to velocity sa B over FB. So velocity sa B, again, the same, 3 times 10 to the power of 8 meter per second. This time naka megahertz. So that is 101.9 megahertz. You convert 1 megahertz equals to 1 million. 1 million hertz. Then 1 hertz is equal to 2 pi region per second. Okay, so solving, we have lambda b is equal to, that is 101.9, 1, 2, 3. Then we have 2 pi. The answer is 0.47 meters. So diri 0.47 meters approximately. So kung inyo na notice class, ang first nga radio frequency nga only 630 kilohertz, lagyo kay hang wavelength. So meaning ang pattern niya kay lagyo kayo nga ni iha pattern ani. Ato ni visualize nga niya pattern, lagyo ang iha wavelength. So that the measurement of lambda is kani siya, lambda a. Whereas for the second radio frequency, since kanang kuan man siya, since gamay siya wavelength, tungod kay dako kay siya og frequency 101.9 megahertz. So therefore iya pattern kay mo repeat dayon in a short period of time. So this one is the wavelength alpha, lambda b. So dako kay diferensya class. Manang kung gamay mo frequency, kuan po mo wavelength, taas mo wavelength. So taas mo wavelength, then kung dako kag frequency, gamay mo wavelength mo nang paspas kaayo. Paspas ang propagation. Okay. So let's proceed to the next problem about Young's modulus of a bone. So again, this is an indirect method to solve for the Young's modulus without having the knowledge on the tensile and compressive strength of the bone. So here we have a given sa problem. So yung man diri, find the Young's modulus for a bone if its specific gravity is 2 and the velocity of sound in the bone is 2.8 times 10 to the power of 3 meters per second. So given here, naratay speed of sound sa bone, that is 2.8 times 10 to the power of 3 meters per second. Again, ang bone solid na siya, so makatravel ang sound dira, and a sound is a longitudinal wave. We have a specific gravity, that is Sg, is equals to 2. That is the specific gravity of the bone. What is to find here is the Young's modulus, that is y of the bone. So to solve for the Young's modulus, so solution. So kay ba naman ta for solid, so for solid we have velocity is equal to the square root of the Young's modulus divided by the density of the bone, diba? Velocity of the bone here. Now waman ta kay ba density sa bone, but we have specific gravity. We all know that the density, the specific gravity, but we have here, but Sg is equals to density of the bone over the density of the water. So therefore density of the bone is equals to Sg times the density of the water. So muna to i-plug in na raa. So we now have here, this one is equal to the square root of the Young's modulus all over Sg times density of the water is equal to the velocity of the bone. Now, solving for YB, kasi YB man itong ipangita. So, solving ni YB, take the square root on both sides. Okay, take the square root of both sides of the equation. So, we now have nanatadira kuan VB squared is equals to YB all over SG times the density of the water. Solving YB, so we have YB is equals to SG densities of water square sa velocity. So SG is 2, density of the water is 1000 standard kilogram per cubic meter. Velocity here is 2.8. So 2.8 times 10 to the power of 3. This is meter per second. Squared man, so expected this is meter squared, second squared, so makancel din, ma-meter na lang. Kani siya kay makuha na siya second squared gapon. So we all know that kilogram per meter second squared is equal to Newton per meter. I mean Newton per meter squared. That is for Young's modulus. So solving this, we have YB is equals to 2 times 1000 times 2 times 1000 times 2.8 times 10 to the power of 3, then squared kay VB squared man, square man sa velocity. So we have here a huge value of our modulus. So we have here 1.568 times 10 to the power of 10 Newton per meter squared. Actually, we can convert this into gigapascal. I-move lang na to og usa ka decimal place array, may siyang 15.68 times 10 to the power of 9 Newton per meter squared, or our Young's modulus is 15.68 gigapascal. Muna siya ang ato ang Young's modulus sa ato ang bone. Okay, muna siya. So let's proceed to the next example. So we have here a sonar device, but ato pa i-drawing. So this is a real application na. Nindot na siya. So please take this one. Take note with this. So let's say natay sonar device class. We have a sonar device. Yeah, diri gamit na siya sa search and rescue. So pero indirect way ni siya mini map kung asa to dapit ang asa na dapit ang shipwreck. So let's say this is mo siyang tubig diri so na tubig diri and below that one of course na ay kadtong mga boulders sa ilawom, so mostly sand, rocks, pebbles, so on and so forth. And below that one is nanatong shipwreck. So let's say mo ng shipwreck. So siya sonar device. So kaning sonar device mo give off na siya og kanang sound waves. Yeah, mo travel na ang sound waves sa ubos. So mo travel na siya. And then once makita na siya og kanang medium, so mo bounce off po na siya. So here let's say ang measurement, so we have here a distance measurement. So from sonar to water natay 50 meters meaning naglupad man ning sonar. And then from the water surface below ngadto sa seabed, this is 100 meters. And then ang thickness sa seabed nga nagbaon aning ato ang ship nga nalunod is 20 meters. Okay. So kanit siya high-end kani nga sonar device, so iyang gyapon ning madetect ang barko. So let's say may release og kanang sound waves ang sonar, so mo travel siya first in air, di ba? This is air. The medium here is air. Pag so the surface, tubig na po ang medium. So we have air, we have water. Finally is we have here the seabed. So man siya nindot ng application. This is the seabed. Again, ang question ni ani is tanda to question. We're going to solve for the total time to reach the sound, okay, to reach the sound wave sound wave at the bottom or at the ship's body and back to the sonar. Okay, kay mo bounce back muna ato ang sound waves. Kay di ba, sound wave is a longitudinal wave. So balik siya, ma-reflect siya mo nang ma-receive kung pila kalawmon ang ato ang ship. So total time ato ang gi-kuan diri, gi-calculate. So here di ba, namatay distance sa tagsa. So therefore naputay time, meaning pila kay time niya nga ma-spend sa air. So that is we have T1 or T sa air, then T pud sa water. Nganong tagsa man nato ang time, tungod kay sa kada medium nga masugatan aning sound waves nga gi-generate sa sonar, lahi-lahi iyang mga velocity. So therefore naay usa hinay velocity, so madugay siya, so mo taas ang time. So solving for the velocity muna, or solving for the time for each medium. So in air, so good for air. Okay, so diri adi ay assume ta nga ang bulk density or ang bulk density sa tubig, we have here B sa water is 1,000 Newton per meter squared. Then diri apod ang Young's modulus sa seabed kay YS is equals to 500 Newton per Newton meter squared. Okay, so for air, automatic kay banata class, dapat yun memorize, air has a K equal to 1.4, diba? And since at normal pressure, sa pressure sa air dira, that is atmospheric, diba? Is equals to 101.101.325 Pascal. So dapat kay bawa na ka ana. So solving for the velocity here, solving for the time. So time is just equal to the distance all over the velocity. And we know that the velocity for air is equal to the square root of ito ganiha, the K multiplied by the pressure of the air all over the density of air. So kuwang patag usa, we have the density di. So density of the air is equals to 1.21 standard kilogram per cubic meter. Okay, so diri So balik ta. Ato pang substitute. We have a distance, di ba sa air natin distance na nata. That is 50 meters. So plugging in, distance is 50 meters all over the square root of K is 1.4, the pressure is 101,325 Newton per meter squared. Density of air is 1.21 kilogram per cubic meter. So unit analysis sa ubos kay nata diray this is kilogram meter per meter squared second squared divided by kilogram per cubic meter. Cancel ni ma-cancel ni ma-meter squared na diri aw ma-meter multiplied sa so we have here meter squared second squared, so this is velocity kay square root ni ma-meter per second. Since na meter sa numerator, so ang answer here is second na lang gid. So therefore the time for air, T for air, is equal to 50 divided by the square root of 1.4 times 101,325 divided by 1.21. So the answer is 0.15 seconds. Pas kayo. So that is 0.15 seconds approximately sa air. Now next is for water. Kedua is for water. Again, ang atong kailangan nga mga parameters is the bulk density of water 1000 Newton per meter squared. Then assume value rin siya class. Density sa water is 1000 kilogram per cubic meter. So for water, the time there, so T sa water is equal to the distance traveled sa ato ang longitudinal wave sa water, that is 100 meters all over the square root of the back modulus divided by the density of the water. So the distance here is 100 divided by back modulus is 1000 all over density is 1000. So therefore, pila may time niya na. So that is 100 seconds. Diba? Makancel man na. So 100 seconds. Therefore, dugay siya. So 100 seconds. That is the time yan spend sa tubig. Katulo, that is for seabed. Sa seabed, this is solid. So, dapat nita og yang modulus. So, that is 500. Assume value na siya. 500 Newton per square meter. Then, density of the seabed. Assume density is equal to 1,500 kilogram per cubic meter. So density is equals to 1,500 kilogram per cubic meter. So therefore, ang time sa seabed ria, T sa seabed is equals to the distance, that is 20 meters na lang, all over the square root of the Young's modulus all over the density of the seabed. So that is 20 meters divided by the square root of the Young's modulus is 500 Newton per meter squared divided by density is 1,500 kilogram per cubic meter. So the result here is still in seconds. So we have 20 divided by the square root of 500 all over 1,500. The answer here is 34.64. 34.64 seconds. So ang time di ay therefore Therefore, ang total time to reach at the bottom then back is equal to T is equals to 2 times T sa air plus T sa water plus T sa seabed. So that is 2 times sa air kay 0.15, sa tubig kay 100, sa seabed kay 34.64. So the total time here 2 times 0.15 plus 100 plus 34.64. The answer is 269.58. 269.58 seconds, or divide by 60, that is 4.5. That is 4.5 minutes. So nga nakapaspas maka-receive og signal dayon ang sonar ngadto gikan sa ship nga nabaon sa seabed. So man siya ang principle sa sonar. So mo travel siya sa air, mo travel siya at different mediums. So man nang na-generate ni siya nga technology. Okay, man niya total time. So pwede po mo mag-research ano niya nga field. Okay, so let's proceed to the transverse wave. Okay, so since man naman tag-quantify sa longitudinal wave, so ato na po i-quantify ang transverse wave. So ang pag-measure ng transverse wave class usa sa mga pamaagi is by using the sonometer. So nani siya sa inyong kuan, sa inyong kanang module, and it is a device that specifically measure the transverse wave of our string nga nag-vibrate, or atay kuan vibrating string. So ma-produce anang a wave kay a transverse wave. So natay vibrating string. And for a kanang sonometer, actually associated na siya with different parameters. So the first one is we have tension. Kaya ang namatay spring, so 10T. This is for tension. Of course, we have mu. This is the linear density. So this is actually this is kilogram per kan siya. Linear mass density din siya. Linear mass density. So kanang mag-strum mo sa inyong guitar, so transverse wave ang ma-produce ana. So to ikuan kung unsay frequency niya na mo na maka-hear tag mga nindot nga mga tono sa inyong pag-guitar tungod niini nga pag-measure, pag kan ba ato gi quantify. So linear mass density, the units here is in kilogram per meter, that is mass per length. Okay, so and then next is of course the length of the string or the wire. This is the length. Okay, so duha ka criteria itong pangitaon. The first one is the frequency. Okay, so using the sonometer for vibrating string, the formula is again F gihapon is equal to 1/2 over the length, then the square root of the tension all over the linear density mu. Again, unit analysis nga nung nahimo siyang frequency. So we have inside, I mean on the outside, it is 1 all over the length is in meters, taking the square root of kilogram meter per second squared muna siya. Divide by the mass density, kilogram per meter. So, natay makancel kaning kilogram, but this one mo go upwards, mahimo na siyang meter squared second squared. So therefore, that is 1 over meter. Then the square root here is meter squared per second squared. The final output is 1 over meter, then we have meter seconds. So cancel out, we have radian per second. So therefore, that is frequency. And if you're going to convert that one into hertz, so you just divide that by 2 pi para ma-convert into hertz or cycle per second. So that is for frequency. Now the next one is ang velocity. Velocity of this transverse wave. Again, transverse wave ni siya, meaning the element here is perpendicular to the direction of the wave. So this is not an electromagnetic wave, so lahi ni siya ang ma-generate sa vibrating string, di ni siya electromagnetic wave, but still another type of a transverse wave. So velocity niya, that is v. V is equal to square root of t all over mu, meaning gikuha ning 1/2 L. So mara siya, and by unit analysis, you will arrive meter per second. Okay, so mara ning duha, frequency and velocity, to quantify the transverse wave of a vibrating string using sonometer. So we have here our first problem. Let's say na that I wire with a given dimension. So given wire 50 cm long, so the length here, i-convert na lang nato in terms of meters, that is 0.5 meters. And a mass, na same mass, 6.5 times 10 to the power of negative 3 kilogram. So gamay kayo. Is stretched so that it makes 80 vibrations. So matag nag-stramanig string. Okay, so naa siya 80 vibrations per second. What does it mean? That is the frequency F. When we say 80 vibrations, equivalent naman siya sa 80 cycles. So that would be 80 hertz. Okay, per second man. So 80 hertz. Now, find the stretching tension. So find the stretching tension. What does it mean? Meaning, gipangitao nato ang T, the tension. So, solution. Okay, solution. Using sa katong previous nga equation nga ako gi-discuss. That is for a sonometer, for a wire, or for a vibrating string, or a wire. The frequency is just equal to 1/2 over the length, then the square root of the tension all over the mass density, linear mass density. So since we're after with T, so we can just take the square of both sides. That would be F squared over 1 over 4L squared times T over mu. Solving for T, so we have T is equal to, mahimo na siyang 4L squared F squared, then times mu. So mu. Again, be careful sa pag substitute sa mga values. So we have here 4, the length is 0.5, so that is 0.5 meters, should be squared. The frequency here is 80 hertz, so you need to convert this into radians, kaya imo naman siyang ipang-multiply sa mga dimensions. So we have here 80 hertz. So ma-square gyapon, I mean ato sa i-convert bago i-square. So ato sa i-raise. So that would be 80 hertz times 1 hertz is equals to 2 pi radian per second. Mga siya. 1 hertz, 2 pi radian per second. Then, after that, squared. Then the linear mass density here is mass over length. So that is, okay, ang mu is equals to m over L na siya. So therefore, we have 6.5 times 10 to the power of negative 3 kilogram per length is 0.5 meters. Okay, so unit analysis. We have here meter squared sa first. Diri kay sa second is per second squared. The third is kilogram per meter. So therefore, makancel ang meter, ma-meter lang ni. So the result here is kilogram meter sa baba o sa second squared sa ubos. So indeed, Newton. So a unit of tension. So solution, let's simplify this. Mahimo na siya og 4 times 0.5 squared times 80 times 2 pi squared, then 6.5 times 10 to the power of negative 3 divided by 0.5. So the answer here is 3284.6. So we have 3284.6 newtons. So man siya ang tension nga imong kailangan para makaproduce ka og frequency sa imong wire, that is 80 vibrations per second. So man siya, class. Straightforward ra. So let's proceed to the next one. We have here the density of a sonometer wire of radius 0.3 mm is 7,800 kg per cubic meter. So not a given. The radius here R of the wire is 0.3 meters. Its density is equals to 7,800 kilogram per cubic meter. Find its linear density. So required here is the linear density. So solution, so we all know that the linear mass density din siya. Linear mass density is just equal to the mass of the wire divided by the length. Okay, the length of the wire. So here we have density, diba? We have density. So therefore we can solve for the mass. Okay, we can solve for the mass. So take one, that is but sa tibutang ha, but mass is equals to density times the volume, diba? And the volume of this wire, since wire man siya, that is the volume of wire is equal to the cross-sectional area times the length. Kaya cylindrical na siya. So we have the cross-sectional area times the length. So we're going to substitute that one. So we have linear density is equals to density times the volume is cross-sectional area times the length divided by the length. So therefore makakancel na siya ang length. So what's left is density times the cross-sectional area. So we have linear mass density is equals to 7,800 kilogram per cubic meter. The cross-sectional area for wire is pi r squared, so pi, then the radius here is 0.3 squared. So unit here is square meter, so that is kilogram per meter. So sakto gyud ka. That is a linear mass density. So 7,800 times pi, then the radius is 0.3 squared. So the answer here is 2205.40 kilogram per meter. So that is the linear mass density of our wire. nga kailangan sa atong sonometer. Okay, so let's have another example. That is the velocity of a transverse wave. So here, in diri, what is the velocity of a wave in a guitar string having a length of 0.65 meters? So again, we're going to write the given. So given here is the length 0.65 meters. Para safe mo sa iyong calculation, always naka-meter ang length. And a mass of 3.5 grams. So again, safer in kilograms. So converting this into kilogram, divide that one by 1,000. Okay. So that the result would be, this one is 0.0035 kilogram. Next, when subjected daw to a tension of 250 newtons, meaning we have T here is equals to 250 newtons. Again, sa gipangita diri, required here is the velocity of the wave. So V. Solution. So from our previous discussion, I mean ganiha, diba, we have the velocity of a transverse wave is equal to the square root lang of the tension all over the linear mass density. So since wala may giving a direct ang linear mass density, we'll know that that is the ratio of the mass all over the length. Or in other words, you have square root of tension times the length over the mass. So substituting the values, so we have your tension is 250, the length is 0.65, dapat naka meters, divide by the mass naka kilograms, so we have 0.0035. So therefore our velocity here, 250 times 0.65 times 0.0035, so you have a velocity of 215.48. So velocity of string, paspas kayo manang kusog mo vibrate, 215.47 meters per second. So mana siya ang velocity sa atong transverse wave nga na-produce sa string, sa guitar string, 215. Mo nang madunggan gidayon nato, class. Okay, so let's proceed to water waves. Okay, so we are now on water waves. When we say ang kaning one class, kaning water waves, this is neither kuno siya longitudinal, so neither longitudinal nor transverse. Why? Because kuan mo gani siya ang water waves kato i-visualize mo gani. Actually mag-vary ay kuan. Mag-vary ay katas-on. Okay, mag-vary ang katas-on. So then ang ihapong throw kay which is the lowest point, mo vary pod ang depth pod niya. It depends upon the source of this vibration sa atong water waves. Again, ang water waves doon ay sources, either disturbances. Ang una is maybe due to earthquake, especially kanang kuan gikan sa ocean sa ocean or sa seabed. Then of course kaning sa wind, kanang na typhoon, so di ba bawod kaayo. So ano siya yung mga disturbances or mga external sources nga makapakos sa ato water waves. Or even kung imo tandugon, so ano siya mga external vibration like magkutaw ka sa planggana, so na ripples, na waves, so usa pa na siya. So ang water waves class, since dili man na siya longitudinal nor transverse, so na siya other classification. Ang classification niya, So classified into two parts. The first one is gitawag siya nga um, deep water waves. Deep water waves. So unsa man siyang deep water waves? So kani siyang klase sa wave, sa water wave kay kani siya. If ang yang depth, if the depth of this wave is greater than 1/2 of its wavelength. Okay, of course, ang atong water wave still has a wavelength. Siya crest, so kato siya is show diri. So nagya mo siya lambda. Now, kung ang depth ani niya ang ilawman sa atong wave kay greater than 1/2, so that is deep water waves. So magamit ta ato ang kuan. So diri use basic equation of waves in order to quantify the deep water waves. Kaduha is what if ang depth kay shallow ra kaayo. So manang gitawag na siya nga shallow water waves. Shallow water waves. So unsa ni mga shallow water waves? Actually kung kanang daghan na kay maligo sa swimming pool kasba, so di ba? Kuan kaayo, tandog kaayo ang surface sa tubig. So mo na yung mga shallow water waves. And to quantify that one, we're going to use this formula. That is, the velocity of that wave is just equal to the square root of the gravity of the earth times the height of that wave. So if the height of the wave is 3 meters multiplied by 9.81, so that would be the velocity of the water waves, the velocity of its propagation. So kana siya h, that is ato ibutang label h is the height of the wave, or you can also name this as the amplitude. G is the acceleration due to gravity, that is 9.81 meter per second squared. So mana siya class. So mana siya ang water waves. It is neither longitudinal nor transverse. Maklasify lang siya into two categories: deep water waves and shallow water waves. So kung deep water waves gali ang ato ang problem, so magamit atong basic equation sa waves, katong velocity is equals to frequency times lambda, the wavelength. Kung shallow ra na siya, to solve for the velocity of that water wave, now you use this formula kaning kaduha. V is equals to square root of the Earth's acceleration due to gravity, g, times the height of that wave, or the amplitude. Okay, so let's have an example here. So in dire, a student observed that the two poles were 6.25 meters apart across a pond. So let's say naida ka pole. So mani una, ni kaduha. So the distance is 6.25 meters. Then next, at a certain instance, there was a crest at each pole. So again, ang crest gali class, remember, highest point sa wave. So water wave man ni siya. So deep water waves ni siya. So ang crest na aday crest dira. Of course, na po'y crest sa pikas. Okay. Next, at a certain instance po, there was a crest at each pole and 4 crests. Upat ka crest between them. So mag-draw na po tag upat ka crest. So we have 1, 2, 3, 4. Okay, we now have 4 crests. Then he also observed that it took 5 seconds for a crest at one pole to reach at the other pole. So meaning kaning first crest kani siya di ba kay bowed man ni, so ang bowed mo travel pa na siya from one pole to the other, and it took this wave 5 seconds before it reached to the second pole. So 5 seconds ang time dira. Okay, 5 seconds. So now he also observed that it took 5 seconds. Then what was the velocity of the wave? Ang say velocity sa wave, so that is the first requirement. So I'm going to put here required velocity of the wave. Next, how many times would the water rise and fall at each pole in 1 second? Okay, so n, atari ko n, number of times the water rise and fall at each pole times the water rise and fall in 1 second. Okay, so solution ini first is we're going to solve for the velocity of the wave. Again, since wala given ang wavelength, so what we need to do here is just use the fundamental fundamental formula for velocity. That is, velocity of the wave is just equal to the distance all over the time. So we have a distance between two poles, 6.25 meters, divide by 5 seconds. So we have a velocity na sa ato ang wave. That is 6.25 divided by 5 seconds. So that is 1.25 seconds. So we have here 1.25 meter per second. So that is the velocity of our deep water wave. So na di kaduha, katong how many times? So katong n. We're going to solve for n kung kapila daw ka beses nga mi isa, so naka-form siya crest, unya naka-form po siya throw in 1 second. Okay, in 1 second man. So here, para makakuha ta niya na nga kuan number of times, we need to know first the frequency of our water wave. So solving for the frequency, diba, we'll know that velocity is equals to frequency times the wavelength, diba? And here pila may wavelength na to diri so kay ba since we know that diri na amantay pila ka waves na to na generate, so diba ang number of waves kay magdetermine sa pattern. So ang pattern ani is from top to bottom. May top first wave, top bottom top second wave, top bottom third, then top na pod, bottom to top fourth, bottom to top fifth. So therefore between these poles na ay 5 ka mga waves. So pilay kanang measurement sa kada waves, that is lambda. So therefore solving for f here, so f is equals to the velocity over lambda. So we all know that lambda is just the distance between these two poles divided by 5. So we have velocity of 1.25 here. Lambda is 6.25 divided by 5. Okay, 5 waves muna. Yeah, kani kay meter per second. So therefore our frequency here 1.25 divided by 6.25 divided by 5. So the answer here is 1 radian per second. Okay, or meaning kanin siya meaning one cycle na siya. So this one is one cycle na siya. Kay gi ko naman to, gi-assume naman to nga ang usa ka cycle is mani usa ka wavelength kani siya. Kani. Meaning kausar din ni siya mo occur. In 1 second usara ka cycle, di ba? In 1 cycle kay ba beta nga in 1 cycle or in 1 cycle class ang pattern sa wave kay mo rise siya, then mo fall, then mo balik. So therefore kaning duha mo occur is only 1 second. Kay this is the visualization of the frequency. Kung you have 2 cycles, meaning sa usa ka second ikaduha na siya mo rise o mo fall. Mo na siyang representation. So therefore the answer here is only once. Wala siya class. Again, din siya region kay since atong lambda diri is naka-define na siya nga per wave, like the measurement per wave. So therefore in one wave dira po na define nato nga that is corresponds to 1 cycle. Okay, so that is wave per second. So naman diri kani i-retain ni dapat kani siya nga unit kaning 5 waves that will correspond to our cycle for our frequency. Okay, so therefore the answer here is only once. Kausara. Okay, so let's proceed to the next. So the sound wave. So kaning sound wave class again, this is a longitudinal wave. So longitudinal wave. So therefore mag-need siya og medium para mako-travel siya. So that's why I have told you earlier ang sound wave kay di siya mo-travel sa vacuum. So kung naka-vacuum wa kay mabatian. Then for sound wave class, according to Newton, to quantify its speed, I discovered in Newton that the speed of sound is influenced by temperature. Especially for air, temperature T. Okay, and in equation, that is the speed V is equals to 331 plus 0.6 times the temperature. So this is in meter per second, and the T here should be in degree Celsius. So let's say at an air temperature of 25 degrees Celsius, major standard, so what would be the velocity of air there? So 331 plus 0.6 times 25. So the answer is 346 meters per second. So yan siya class. Yan ang pagkuha or pag-quantify sa speed of sound. Under another quantity pod to define the sound or the speed of sound is by using this Mach number. So Mach number. Importante ning Mach number because the Mach number M is the ratio of the speed of sound of the source all over the speed of sound in that medium, in a medium. good example niani is, let's say we have a jet plane. So natay jet plane dira So of course nag-travel na siya, and sa iyang engine na siya ay emit na siya og sound. So that is the speed of sound sa source. Unya, of course mo travel na ang speed of sound sa medium. So naman na siya kuan, naman na siya na siya value diri ang value sa speed of sound in a medium can be calculated using katong pwede po tong square root of kp over the density. Okay, or you can use this speed of sound in air. Kani siya, this is for air ni siya, class, for air. So you can also use that one depende sa temperature. So if ang atong Mach number, so tika na tayo mga conditions ari. If m is less than 1, kani siya gitawag ni siya og subsonic. So meaning below siya sa speed of sound normally in air. If Mach number is greater than 1, mo siya gitawag nga supersonic. Meaning na ay sonic boom nga mahitabo. Sonic boom. So manang kung sa mga jet plane na siya mura og may condense nga kuan, kung paspas na sila, so na siya air, mura siya cloud dira nga ma-form sa ilang atubangan. So kana siya, that is the result of the sonic boom. So na condensation nga may occur dira. So na air condensation nga hitabo tungod kay mi-exceed na ang iyahang speed. Okay, mi-exceed na ang speed sa ato ang jet plane sa speed of sound inga na nga medium. So manang ayang Mach number niya kay greater than 1, so supersonic na aya tawag. So kung less than 1 lang, subsonic na siya. Okay, so that is for sound. Again, sound is a longitudinal wave. Then to quantify the speed of sound in air, you can use this one because the formula is a function of temperature. So that is 331 plus 0.6 times the temperature. So the higher the temperature, taas pa ang sound. And here for the speed of sound, again, don't forget to use those equation atong gidrive o giswat kagani ha. Kaning velocity for the speed of sound for air, that is square root of the specific heat ratio times the pressure all over the density of the air. Okay, so thank you for listening and have a nice day.